Ignition sequence start. 5, 4, 3, 2, 1. Liftoff. We have a liftoff.
Good afternoon, ladies and gentlemen. I'm Kevin Chilton, Explorer Chair for the Mitchell Institute Space Power Advantage Center of Excellence. And welcome to the release of our new report, Winds of Change, Environmental Monitoring for an Era of Peer Competition. Weather impacts all levels of warfare, from the operational to the tactical, in all terrestrial domains, sea, land, and air. We all remember the story of how General Eisenhower's decision to launch D-Day hinged on a weather forecast. I could go down a long list of similar examples where weather was a make or break factor. As we move to more collaborative operations, thanks to concepts like JADC2, environmental data will be especially important for closing tactical kill chains. It all comes down to getting the right set of actors to the right place at the right time with the right equipment to provide the right effect. And weather is a key factor. Weather conditions can also impact the decision on which weapons to be used. Just think of the impact of a pop-up thunderstorm or low overcast, the impact it can have if you have the wrong weapons on board. It can drive major changes regarding what assets are available to get the job done. If we lack that information, the results can be catastrophic, often more harmful to friendly forces than the most robust enemy defenses. Remember the 1980 Desert One failure. That failure was driven in a large part by unanticipated weather phenomena. Monitoring the weather from orbit is one of the Space Force's most impactful missions. However, the weather mission is often overlooked and taken for granted. Many don't realize that the current space-based weather satellites are old, fragile, and in dire need of reset. And that's what we're here to talk about today, to get a better understanding about the mission and learn about how the Space Force is resetting for its future success. To discuss his report and recommendations, we're fortunate to have Tim Ryan with us, Senior Fellow for Spacepower Studies at the Mitchell Institute. We're also fortunate to be joined by Colonel Pat Williams, U.S. Air Force Director of Weather, Headquarters United States Air Force, and Lieutenant Colonel Joseph Maguadog, Materiel Leader for Electro-Optical Infrared Weather Systems at Space Systems Command. Gentlemen, thanks for joining us. And to kick things off, Tim, I'd like to begin with you presenting a little briefing with a summary of your project. And before you go, Tim, a note to our audience, please feel free to submit questions in the Q&A window anytime during the discussion that goes on during the day, and we'll attempt to address those at the end of the hour. Tim, over to you.
Great, thanks so much, sir. Let me share my screen and get the slides up. So for many of you, you may be asking, why weather satellites and why talk about them now? Well, General Chilton, I think you hit on it. The weather mission has been overlooked. It's been taken for granted. It's one of the less heralded but more impactful missions that the United States Space Force provides. It is time to now actually complete the modernization of these systems that you so eloquently laid out for us. And oh, by the way, and we're going to get into this as we go, this program has been plagued by starts and stops in the replacement programs over the last 20 years with no success. So why now? Well, Congress just passed yet another continuing resolution. These are so harmful to the programs that are needed to defend our nation. Congress' inability to pass an actual budget and dependence on multiple continuing resolutions is problematic. So let me start by setting the stage of what weather data brings to the fight. General, you hit it straight away. Operation Eagle Claw, the special operations mission to rescue American hostages in Iran in 1980. It failed in part as a result of unforeseen dust storms. More than 3 decades later, the successful assault on Osama bin Laden's compound in Abbottabad, Pakistan was carefully planned around troubling weather. Planners delayed the mission by 24 hours due to anticipated surface winds and thunderstorms. Without the ability to accurately forecast weather, that mission might also have been a failure. Think about how you feel when a pop-up thunderstorm delays actions and the game on an afternoon Nats game. Well, imagine that when you're strapped to a bomber traveling across the vast Pacific Ocean. So let's start with, why do we need this? And why do we need to talk about this? Let's start with, as General Gagnon sums up, weather always gets a vote. Importantly, acknowledge that environmental monitoring is not just a supportive function, but a critical enabler of military operations and impacts all levels of warfare while influencing decision-making and aligns with the future CJAD-C2 strategy focusing on information superiority. So how does space-based environmental monitoring, or SBEM, aid in military operations? First, let me draw your attention to the acronym for space-based environmental monitoring that I will use, SBEM, as this umbrella. By having real-time data on weather conditions, terrain, and other environmental factors, commanders can optimize the timing and execution of attacks, ensuring that the right forces are deployed in the right place at the right time, delivering the right effect. Additionally, being able to anticipate an adversary's decision calculus by understanding how environmental factors might affect their strategic choices. Here's the problem. Capabilities and capacity have not kept pace with warfighter needs. The reality is, for too long, the U.S. has relied on a small number of aging satellites, the Defense Meteorological Satellite Program, or DMSP. These satellites are beyond their design lives. Just that is one indicator of why there is such a need for a robust and continuous replacement strategy to bring the space-based environmental monitoring capabilities up to date. For over 20 years, multiple incomplete replacement programs have resulted in this capability gap, leaving U.S. forces without the latest technology and data needed for effective space-based environmental monitoring in the face of evolving threats. The bottom line is this: there's a pressing need for the SBEM replacement programs to be launched on current timelines so they can start to address the gaps left as DMSP comes to its end of life. So how did we get here? Well, delays and cancellations of prior efforts to recapitalize the SBEM enterprise were due to budget concerns and, frankly, the absence of imminent system failures. This is clearly demonstrated by decision makers prioritizing other requirements and not seeing the operational cliff the space-based environmental program was heading to. The first steps taken in replacement was in the 2010s, when the Air Force assessed the mission gaps through an analysis of alternatives, or an AOA. The next step happened in 2016, when a Joint Requirements Oversight Council, or JROC, study was started, and it was intended to show how the SBEM architecture should be recapitalized and the capability gaps that will be needed to be addressed. Now, as you can see from the chart on the screen, even as these studies were happening, DMSP end of life was looming and no replacement program was yet identified. So through this analysis and the studies, that led to identifying the Electro-Optical Infrared Weather System, or EWS, and the Weather Satellite Follow-on Microwave, or WSFM, programs as their way ahead. Now, it's not time to repeat our past practices with the SBEM replacement programs. They must have the continued support and funding that is crucial for successfully implementing these recapitalization efforts. So what are some of the challenges facing it? First and foremost, the current looming DMSP end of life is a good place to start. DMSP, with its roots in the 1960s, has a long and storied history of providing critical environmental data for military operations. Despite its historical significance and continued demand for its services, the reality is, as I highlighted before, the program has not been maintained or modernized. That's resulted in a situation where there are no spares, sensor upgrades haven't happened, and there's no replenishment satellites on orbit in the Space Force. Knowing DMSP is on its last legs, leaders have augmented the U.S. SBEM capabilities with a family of systems approach that combines data from other weapon sensors on orbit through partnerships with NOAA and U.S. allies. While a helpful augmentation initiative, this workaround must not be confused for a direct replacement for DMSP. Certain types of SBEM capabilities, zones of coverage, and refresh rates are very military specific, and this is just a band-aid. Much has been discussed about looking at Starlink and their possible impact on supporting Ukraine operations, and as you can see from General Van Herk's comments above, the need for an organic defense-supplied weather data is how you will ensure that you will always have it. So focusing on the required information and decision advantage is an emphasis on delivering information at the speed of relevance, focusing on real-time decision-making and responsiveness to rapidly changing operational environments. So what's the role of SBEM in this environment? The ability of SBEM to provide highly accurate, short-term forecasts is critical for planning and executing operations in a rapidly changing environment, especially in remote regions where the adversary denies access. Consider the benefit to U.S. commanders who can anticipate an adversary's decision calculus based on weather information. For example, where they're likely to move their forces, what weapons they are likely to employ or not based on weather conditions. To give you another example, the Air Force's Agile Combat Employment, or ACE plans. These are designed to geographically disperse forces to provide a U.S. advantage and frustrate the adversary. These decisions on where and when to disperse will be underpinned by the critical data provided by SBEM capabilities. Operations in adverse weather conditions have often proven more harmful to friendly forces than most robust enemy defenses are, as you highlighted earlier, General Chilton. Based on these real advantages that SBEM capabilities bring, the concern is, in a future operational concept, will the architecture have the revisit rates that will enable the decisions to be made in hours and minutes across an entire theater? So what does an SBEM replacement program need to have? Well, the following chart shows the 12 mission capability gaps identified in the 2016 JROC study I spoke about earlier. Now, DMSP was designed and configured when space was generally considered a peaceful operating domain. The enterprise was engineered and purpose-built to be a large-scale, highly capable, multi-functioning system. While efficient and capable, it is a prime example of a, quote, big, juicy target and is highly vulnerable to enemy attack. Disaggregating the mission across multiple satellites contributes to the overall resilience of the architecture. Space Force has made it clear that resilience is crucial in military operations, especially in contested environments where adversaries may attempt to disrupt or even disable critical capabilities. This approach also aligns with the Chief of Space Operations' operational tenet of denying first mover advantage by distributing the mission, and Secretary Calvelli's acquisition tenets, in particular, you build small, you use existing technology and reduce non-recurring engineering. You take advantage of commercial capabilities and you execute. We cannot repeat the history of this program in trying to replace it, nor can we continue to wait. Just like we've seen with ICBM modernization and the airborne C2 capabilities, the right time to replace is well before end of life or retirement. So let's dive into the programs selected as possible or as replacements. The EO-IR weapon system, or EWS, is built by General Atomics and plays a pivotal role in meeting critical SBEM requirements, specifically cloud characterization and theater weather imagery. And if you remember back to the last slide that I showed with the capabilities, those were listed in priority order, and cloud characterization and theater weather imagery happen to be priority 1 and 2. Characterizing cloud cover is foundational to missile warning timelines, as certain types of clouds may affect the visibility of missile launches or even alter the infrared signatures. Additionally, this is a key planning consideration in selecting sensor and weapon packages. For example, cloud cover impacts the use of laser-guided munitions. EWS also supports theater weather imagery, which supplies real-time information about weather conditions in a specific geographic region. This is particularly valuable in theaters with austere regions or lack of support from terrestrial weather sensors. Think about the mission demand in a combat search and rescue operation. You can see how vital understanding both current and future weather conditions is key. As we all know, military operations often occur in diverse and unpredictable settings, and having the ability to gather accurate weather data in such environment provides the U.S. a strategic advantage. The weather system follow-on microwave, or WSFM, is being built by Ball Aerospace and utilizes a passive microwave sensing for capturing data related to atmospheric moisture, precipitation, and other weather parameters, providing valuable insights into weather conditions. In addition, WSFM provides space environment observations. These weather indications can directly impact satellite communications, navigation systems, and other space-based technologies. In today's daily global mission planning cycle, The requirement is for up-to-date and accurate weather information to optimize military operations, logistics, and decision-making across the diverse theaters of engagement that the U.S. forces find themselves. So as you can see, the sum of these programs meet current requirements. However, the reality is these are from dated analysis. It predates JADC2. It predates the drive for increased resiliency and smaller satellites that distribute the mission across multiple satellites and proliferated orbits. It's more than worthwhile to make sure additional requirements are addressed as these capabilities evolve and mature. And that should include the capacity that will be needed to fulfill CJADC2 warfighter needs. Now, we have discussed what future warfighting concepts will look like, so let's put the SBEM data into those strategies and see what it looks like. This advantage would be leveraged for various military effects, such as planning operations, optimizing resource allocation, and gaining insights into how weather conditions may impact the effectiveness of both friendly and adversary forces. Integrating near real-time environmental information into decision-making processes will enhance the military's overall information superiority and minimize the adversary's ability to exploit those conditions. The 2016 requirements are good. We should not let our foot off the gas in fielding them. But let me show you what I'm thinking about when we talk about future needs. The size and orbital characteristics of the constellation should be based on warfighters' need for real or near real-time information for decision-making. When you look at some not-so-future warfighter needs, let's say commanders need to make operational decisions in minutes to hours across an entire theater, let's say Indo-PACOM, you can see the need for more capacity is real. Just to kind of provide some context for future force design, to be able to meet a 1-hour refresh rate, you would need a minimum of 12 satellites on orbit in a LEO constellation. These are the exact type of requirements that must be considered as the program evolves and matures. Now, I identify 5 recommendations in this policy paper. The NDAA should fence EWS and WSFM for defense requirements only and avoid repeating the past delays. The U.S. military cannot afford to see this cycle repeat. The Space Force is on the right path with the Chief's tenets in his theory of competitive endurance, coupled with how Secretary Calvelli is driving acquisitions. And now is not the time to change paths. I detailed what a CJADC2 operating environment would look like and how SBEM underpins how commanders will make decisions. Meeting these emerging future needs must be identified and planned for now. As the program matures and develops, providing both long-term and stable funding with a program of record that addresses the warfighting requirements is vital. As the DoD continues to partner for SBEM data, they must ensure that it is from reliable sources and will be available through all phases of conflict until there is a DoD-controlled and operated constellation of SBEM capabilities. I can't think of any better way to sum this up than General Thompson's words on the screen. Every DoD operational mission begins with a weather briefing, either space or terrestrial weather or both. The data required for DoD missions is often unique and necessitates 24/7 global ability to forecast weather in austere and denied environments. And with that said, sir, I will hand it back over to you.
Thank you, Tim. That was a great overview of the paper and an exceptional paper, which I encourage all of our viewers to download and read after today. And with that, I'd like to give both Joe and Pat an opportunity to comment. I'm going to start with Pat. Colonel Williams, you're in the headquarters, the director of weather, and so your fundamental job is to argue for requirements fulfillment and get the money so that you can pass it on to Joe to buy these systems. And I think our audience would really value hearing from you on this subject matter, particularly on why we need to refresh these constellations and what it will mean to us when we do. And if you check your microphone's unmuted, Pat, thanks.
I apologize for that. Okay, there we go. Well, first off, thank you, sir. Thank you for inviting me. And also thank you to the Mitchell Institute for allowing me to come in here today. And happy Thanksgiving to everyone for the end of this week. I'll start with a brief overview, and then I'll get into specifics on why the SBEM piece matters so much to what we do. So Air Force Weather provides operational capabilities directly to the Army, the Air Force, and the Space Force. And we believe that the weather drives behavior and influences operations. It can also be exploited to create offensive opportunities, and I'll dive into a little bit of that as well. In general, weather capabilities come in two flavors, the way I like to look at it: an execution piece and a planning piece. Within the execution piece, we have mission generation and we have resource protection. That's mostly for our blue forces. That's for our friendly forces that we have in the field or wherever we're trying to get after. How do I get an aircraft to take off and land safely? If something's coming in, how do I protect the resources that we have on the ground? The other part is the planning piece, and that's where we really determine the when and the where to soften that battle space and present offensive opportunities for our strike capabilities. And here we're focusing mostly on the red forces, or our adversaries, and that was kind of mentioned in the previous presentation by Tim as well. And we really get after that aspect of weather at that piece as well, and that's mostly in the planning aspect of it. So as we go through both execution and planning first, obviously, we have to partner with a myriad of different allies and people. So from an operations perspective, we partner with the Navy, the Marine Corps, and Special Operations. We partner with the interagency, NOAA, the National Weather Service, Department of Energy, the Department of State. We can go into that if you'd like. We also partner with the industry and academia. We're always looking for best of breed, latest technology, latest sciences. And then, of course, importantly, we also partner with the world as a whole, partners and allies, our Five Eye partners, NATO countries, Korea, Japan, so on and so forth, because as was mentioned, we don't always have all the assets that we need when we need them, so we need others to help us out in that case. And until we can have our own reliable, relevant data at our fingertips, we have to rely on others, and there's a danger in that as well. But right now, they're all willing participants, so that's a good thing. Our forecasters need our data to conduct operations, and SBEM is really the primary source for us to be able to do that, especially in data sparse environments around the world. The impacts to SBEM's family of systems, or the lack thereof, really impact more than just the Department of the Air Force. It really impacts global operations. I think that was succinctly said at the last slide in Tim's presentation there. So as you can tell, a lot rides on SBEM, and I thank you all personally for inviting me to have this conversation. I'm very passionate about this. And so thanks. I didn't want to take up too much time for this intro, but thanks for having me on board, and I'm looking forward to the questions. Over.
Thanks, Pat. And I'm sure we'll dive deeper into your area of requirements, et cetera, as we go through this. Joe, you're on the front lines of fielding these systems for our warfighters at Space Systems Command. I'd like to give you an opportunity to talk a little bit about how things are going, your challenges, and what you're going to deliver.
Absolutely. Thank you, sir. I appreciate that. And as Colonel Williams said, I really appreciate the Mitchell Institute's push to ensure that this story is shared with the community, because it's a highly important mission area that we take very seriously out here at Space Systems Command. I would kind of reiterate some of the things that Tim went through, and he was highlighting essentially over 50 years or so, we've had one large satellite with multiple capabilities, and that is DMSP. And as Tim kind of highlighted, it is absolutely time that we advance that technology and put up a proper replacement. The Space Force kind of has a suite of SBEM capabilities that our operational community needs, and we're pivoting that mission area to an increasingly disaggregated, proliferable, and ultimately a more resilient architecture that aligns to our CSO's vision. And as he also mentioned with Secretary, our Senior Acquisition Executive, Honorable Calvelli's tenets, ultimately we're trying to drive towards a smaller and cheaper capability. We've got to ensure that we meet our operational community's needs, and we are trying to keep all those things in mind as we are working with industry to ensure that happens. The partnerships with NOAA, our allies, have and will continue to be a key to our success. And so, for example, compared to DMSP, our current SBEM programs, as Tim eloquently described, EWS and WSFM are on track and will provide advanced sensor technology while continuing to leverage and enhance the key partnerships that we leverage today and we are laser focused on delivering that needed capability going forward. EWS in particular has some exciting things that are coming up over the next couple of years as we are trying to drive towards that vision of how small and affordable we can make this architecture, but at the end of the day, ensure that our operational community can take that data, right? And so we've got a CubeSat technology demonstration that is on track to launch in March of 2024. We've been working with a non-traditional vendor called Orion Space Solutions. And so that technology demonstration is really us trying to push the bounds of how small can we make this? And you know, the CubeSat, I'll say probably the size of a shoebox, right? Is us really just trying to look into the technology, understanding that there's so much more work that has to be done to ensure that if you've got a ton of these small satellites going around, that our users can deal with that level of information, right? So lots of things that we've got to study there, all the while knowing that we have to replace DMSP, and the EOIR portion in particular, as Tim highlighted, goes after our top 2 requirements in cloud characterization and theater weather imagery. So we've got an operational demonstration that General Atomics is taking care of for us that is on track to launch in 2025. So I say all that to say, as we are trying to look to the future and ensure that we are providing a menu of options that are scalable, that can meet the need in the most affordable way, we are constantly evaluating the commercial community and ensuring that whatever solution that we can find can meet the need of our operational community. And we're absolutely getting after that. So I really appreciate the time that we're going to take today to focus on this mission area and look forward to the discussion. Thanks.
Terrific, Joe. Thanks. If I could comment or ask a question based just on your opening remarks there, oftentimes when we talk about smaller off-the-shelf systems, oftentimes we think less capable. Now, DMSP has been up there for a long time. And so I would assume a lot of technologies coming forward that will be deployed in the SBEM architecture will in fact be more advanced systems. So I just want to confirm that we're not only going to get disaggregation for survivability and increased revisit times, which are necessary for the tactical fight, but the technology is still advancing as we do this. Is that fair to say?
100% accurate, sir, right? I think our DMSP is that 70s, 80s technology. And so as you can imagine, our ability to look at the advanced technology today, that kind of gives us that opportunity to get much smaller, right? And much more affordable. And so we are absolutely looking at ensuring that we're not only going to meet the need of what DMSP has providing, but we're going to provide much more capability going forward. And a lot of that is because of all the advancements in the weather side of the house today. So you're spot on.
Terrific. Pat, if I could turn to you as the Director of Weather for the Air Force, but also the former 557th Weather Wing Commander. You know this business as good as anybody in the United States Air Force or Space Force. Tim brought up a point in his briefing about we not only need to meet the CONOPS of the past, but as JADC2 comes on board, and you've got this broader collaborative environment that includes all domain sharing of situational awareness. Will this constellation support that, or if so, are there any changes you need to consider as you move forward in the deployment of it to provide true collaboration and for the weather portion of the information required to plan and execute a mission?
Yes, sir. Thanks for the question. So I agree. So weather can obviously change the battle space and really turn the tide of any battle at any time. And so having that information at your fingertips when you need it becomes a turning point. And so with all the technologies and all the advancements that we have that is probably going to go up in space, if we can get that down to the individual operator, the forecaster, who can then translate that into mission operations, that's the part that we need to really be able to focus on. Will it change the way we do business? Slightly, because we're going to have better information to be able to have to forecast what's going to happen. I'll give it a quick example. On an execution piece, as an example, this was back in 2003 in Iraq. I was with the Army, and they have what they call a CAB, a Combat Aviation Brigade, was where they, for the most part, manage all their air assets that's on the ground, and they focus on 5,000 feet and below. One of the things that they do is when they know that there's going to be an operation going to happen where they might have troops in contact, they pre-stage medevac within a radius of where that operation will occur. So if they need to evac wounded, they can and get them to care in that golden hour to save people's lives. And so where we came into play is we would look at satellite imagery specifically and try to figure out where was the best place to pre-stage medevac, specifically to do these troops in contact situations. And so when we talk about how do we do that, if we can have that information proliferated across the board, just like in that particular operation, now we're talking to an infantry unit, we're talking to an aviation unit, we're talking to an Air Force unit who's providing CAS support from the top. We're providing, across the joint force, all for a specific set of operations. And that's kind of at the tactical level where we can all chat collaboratively together, side by side, and have that conversation where you can have the expert right there with the data that they need to be able to interpret it to execute the operation. Same thing on the planning side. As we foresee things occurring on the planning sector, we can look at the same thing from the adversarial perspective. Hey, we know that the adversary cannot launch at these times because their runways are going to be socked in or whatever the case is. Maybe this is a great time to maneuver or move in or do whatever you want to do, and then we can get after that. From a humanitarian perspective, even we can look at satellite imagery. We can start to forecast through climatology as well when droughts will happen, and that's when we work with the Department of State, and then the DoD gets called in to figure out, okay, what are the competing tribes for that same water hole? And so maybe we can find some other ways and solutions so that these tribes don't start to fight with each other, so that our national interests aren't at jeopardy and at risk. We could also do it for humanitarian and disaster preparedness and disaster relief missions as well. As we see hurricanes or we see some sort of intense storm coming to a particular zone that we know they can't support any sort of devastation, we can prep and be ready to do that as well. But that's all the planning aspect of being able to collaboratively talk, and all that data is coming from the SBEM satellite constellations that we would need. So when you couple all that together with the mission planner and some other soft power capabilities like cyber, intel, and public affairs, you really have a capable you have a different outcome that can happen on the back end that you may not need a kinetic result for. You could probably create a similar effect non-kinetically, and that might probably be a better way now. So 100%, I think it'll definitely help in more than a small way. Over.
Great, thank you. And Joe, anything you'd like to add on this particular subject area?
I would just say from an acquisition perspective, it is extremely important as we're looking at all these different options with advanced technology and what industry is doing, that we are staying connected to our operational community, right? Because if our users cannot ingest the data or the data is not operationally viable, then we're going to consider that a failure. And this is a no-fail mission area. So continuing to stay closely tied to our mission partners that include our users, our data architects, all the folks that Colonel Williams was kind of describing, is what's going to keep us on the right path, and we've been absolutely focused on that with EWS.
Great, Tim. Anything you'd want to add?
No, so I think that Pat's, operational and tactical examples are, spot on. Exactly what we talk about when we say, as we evolve and mature these capabilities, looking at the future, there obviously is going to be, there's a driving warfighter need that probably needs to be addressed and made sure. And Joe, what you and your team's doing out there by staying, in lockstep with that, we make sure that we've kind of across both sides of the fence, if you will, the ops and acquisition side, have an actual understanding of what the future technologies that are needed to be able to fight in those future concepts. So I think that's great.
Great. Hey, I mentioned disaggregation, and so did Tim in his report. I don't think it hurts to ever hit on why we're proceeding down this path. Joe, any comments you would provide on the advantages of disaggregating, which means rather than putting all the sensors on one payload or on one bus, one big satellite, to spread the mission sets not only across different constellations and satellite designs, but also different orbital altitudes?
Yeah, absolutely. I mean, I think many of us have heard, our Chief of Space Operations and other Space Force leaders have continually highlighted that space is a growing and contested environment, right? And so So General, as you spoke to, the more we can disaggregate capabilities and not be stuck on one particular satellite, to where if the microwave portion fails, essentially you start losing the whole capability, right? And so if we're able to put up these disaggregated capabilities that can focus on certain mission areas, and they are as small and as affordable as possible, our ability to rapidly put something else up or scale that refresh capability by putting more of them in the architecture. All of that flexibility, I think, is important and is part of the vision for what we're trying to do in SBEM.
But from the acquisition point of view, I mean, I think you just gave a good description of the requirements and why we need it, which is what I asked. But from an acquisition point of view, does it make your job harder to field these disaggregated constellations?
Yeah, absolutely, sir. I think in particular, the example of the CubeSat demonstration that we're doing, there is a vision of disaggregating and making this capability smaller. The challenge is, if I need, we'll say, 15 CubeSats to do the same job of one small sat that covers a certain area, the ability for us to give that viewpoint of a particular part on the globe the same as one satellite with a larger swath width that just starts to be technically complicated. And to compound that technical challenge, when our users aren't used to dealing with data in that many ways, do we have the ability to ensure that it could be stitched together, for lack of a better word, so that they are not impacted by us providing so many data sources, right? Mm-hmm. So I would say it absolutely makes it more complex as we are trying to drive towards a certain vision of even more disaggregation for resiliency's sake, but ensure at the end of the day, the most important thing is that our users can use the data, right? And balancing that in the most affordable way possible is absolutely part of the challenge and the complexity of delivering that next gen capability and doing it the right way, which is ensuring that they can use the data.
Would you agree there's also an advantage to this approach that kind of meets one of Secretary Calvelli's requirements, and that is, be able to refresh the technology more frequently. Is that fair?
100%. And I think Colonel Williams, do you have a comment, sir?
Yeah, please.
Yes, sir. Thanks. So on the disaggregation piece, and there's a balance, and I completely concur with everything that we were talking about for disaggregation. The other thing we have to keep in mind, and I think it was Joe was mentioning it, as we bring that data in and ingest it, we have to interpolate it, we have to stitch it together, we have to do all that. The more parts and pieces we have, the more latency we introduce into the system. And the more latency we have, the longer it's going to take to get it to the final user, which, what we're looking for is timely information, of course, because that's important. So there's a balance that has to be struck there. I'm not exactly sure what the right numbers are exactly, but there's definitely a balance there. So I wouldn't go full on, hey, let's do 35 micro CubeSats versus 1 or 2 small sats. Maybe there's a balance between the two of them, because we have to still put everything together, authenticate the data, translate the data, and then move that data through a lot of pipes just to get it to the end user at the end of the day, because it has to go secure, and there's inherent latency in that process as it goes through. Over.
Tim, any thoughts?
No, I think that's, this is what we kind of talked about in this report, which is the 2016 requirements are absolutely must, need to be able to get done now. And that's exactly what the team out at SSC is doing with these 2 programs. So now's not the time to be able to change on that. But as we go forward, we've got to be able to take a look at whether it's from Pat talking about how are we going to stitch it on the ground? How is it going to be, transported and translated so that we don't introduce latency, because now all of a sudden the data becomes useless, getting back to Joe, what you kind of laid out. So those are all very, very important as we laid out what tomorrow and the future on that program looks like.
Good. Just looking back on the history of this program, I mean, before I retired, which was a long time ago, we had concern about the DMSP constellation, and we had several starts and stops in the interim on programs to replace it or augment it. And here we are, I kind of feel there's a similarity to the recapitalization of our nuclear deterrent with this constellation as well. There's not a lot of time left for us to do this. It's past time to do it, and we have to go. Can you talk, Pat, a little bit about the pressure to get this done and the sense of urgency, if you will, to actually get this program completed on time and on orbit?
Yes, sir. So this program for us is extremely important. As we look at great power competition, what's going to happen in the future, or we look at what's happening still in the Middle East today, or even in the Russian area over there with Ukraine, we use this data today. Let me give you a couple of tactical examples on why this is so important and why the SBEM data matters so much. From the ground looking up, I can only gain so much information, but from the space looking down at what's happening, we can pull out from that space information all sorts of different information that otherwise we wouldn't be able to have. So as an example, a thunderstorm cell, small thunderstorm cell, can actually form, dump hail, create a microburst on the ground, and then collapse all within 30 minutes. I've actually seen it happen in Iraq. I've seen it happen in Afghanistan, and that's a problem. So when we're talking about Blackhawks, as an example, in the Middle East, they end up with a brownout condition where they can't see anything. And then we actually had a Blackhawk go down in the Middle East as a result of that. The resulting medevac rescue could not make it in time because they had to wait for that frontal windstorm to pass. As we go up in the atmosphere, say 10 to 20,000 feet, we have planned routes between drones, RPAs, other aircraft like tankers, and so on and so forth. These thunderstorms can pop up, these thunderstorms can move around, and if we don't have eyes on all the time, that can definitely affect the route of these aircraft and these operations. These things are electrically charged, these cells are electrically charged, so that's bad for these RPAs, remotely piloted aircraft, and they can cause some significant turbulence. So from humans flying to the sensors on board, severe turbulence obviously is not bad. The higher up we go still, and again, I can't see it from the ground, but the higher up you go still, at the strategic level, it becomes even more important, because how do I keep an eye on what I was actually looking for? So that becomes very difficult for the intel community to kind of keep constant eyes on what they're actually looking for as they have clouds going through. If we can forecast that, we can have multiple different sets of eyes looking at it from different angles if we need to, but if we can't forecast it, that becomes a problem. We have the ability at the wing to push clouds around the world. All this is simulated, of course. And so what that requires is a constant refresh of initial conditions that comes from the true picture from satellite imagery. So satellite imagery will give us, this is where the clouds are, this is the type of clouds and where they happen to be. We can pick out which ones are forming, which ones are dissipating, and where they're actually moving based on wind patterns. And then we can move that around the world, and we can look at that and figure out and forecast where cloud cover might be, which is extremely important to the intel community to determine asset prioritization, all sorts of other parts and pieces. So the SBEM data that only SBEM can provide is uniquely critical for us to be able to do our job so that the warfighter can do their job. So yeah, I agree 100% that this is a sense of urgency because we absolutely need it. As you mentioned, sir, the DMSPs are all but dead at this point. And one satellite isn't really enough to give us enough of a refresh rate. It's just not enough. So it might as well be a dead constellation at this point. Over.
Thank you. And just so we urgently need this capability. Joe, I'm going to go to you. I know the impact of a continuing resolution can mean no new starts, but also can mean no ramp up in a program funding that's anticipated that's required to meet schedule. Are you at risk by a continuing resolution in either of these areas? Are your programs put at risk?
Yeah, General, I think that's always a challenge for all acquisition programs, right? And it's an incumbent upon the program managers to try to anticipate as much risk as possible. And that's absolutely what our team tries to do, working very closely with our industry partners that are building these capabilities, right? I can't emphasize enough how important the success of this program to meet those timelines are so reliant on our industry partners that are literally cranking the wrenches and building these never before made next generation sensors. And so staying in constant contact with them, and their ability to work with us if we run into fiscal challenges, but continue to keep moving the ball forward is absolutely our focus, right? And I think as Tim kind of went through, this mission area has dealt with various challenges through the years. It's complex, and we've just worked hard now to try to accomplish the goal for our operational community, and we're on a great path to do so. So controlling costs, staying connected with our operational community, keeping leadership in Congress informed on progress, and then working closely with our industry partners has been a recipe for success. And we are trying to deliver under budget and ensure that no matter what happens, we are best postured to keep moving forward as much as possible.
Great, thanks. In line with the Chief of Space Operations lines of effort, partnering to win, I was wondering if any of you could offer your thoughts on the family of systems approach as the Space Force fields these program. And as you talk about that, is there any tension there between that approach and commanders' requirements to have organic weather capabilities?
So I can go ahead and start if you'd like.
Yeah, would you, Pat? Thanks.
Yes, sir. Again, we talked about the disaggregation of these different satellites and that approach. It's a very sound approach, and it has a lot of benefits as well. There are some cons that I think that we can, or some gaps even that I think we can mitigate. And so when we talk about a commander's want for organic weather capabilities, I think what we really need to look at is what is it they're really asking for. It's been my experience that they're asking for really reliable and trustworthy weather capabilities versus somebody who is shoulder to shoulder necessarily. What they're looking for is dedicated weather capabilities to their mission and to their operations. And we can provide that in a multitude of ways. Technology is fantastic. So having the disaggregated satellites, whether they're polar orbiters, low Earth orbiters, geospatial geo orbiters, gives, at least from a science perspective, gives us as the operator who is interpreting that data multiple viewpoints, multiple ways of looking at the data, and multiple ways of looking at the atmosphere and the space environment to provide battlespace awareness to the commander that they so urgently need. Just think about almost a year ago, the Russians got stuck in the mud, right? So some of the capabilities that these satellites can provide is soil moisture. Well, we use that soil moisture for a variety of different things. One of those, obviously, is trafficability. Can I get cargo? Can I get things through particular routes of passage? And if I can't, is there another route? Conversely, looking at it from a red perspective, know that certain roads are going to be washed out, or certain rains will wash out with a mudslide certain roads, and they're going to be forced into a very specific avenue. Okay, that creates a natural bottleneck that you can take advantage of. Knowing that information is key, and the only way I'm going to be able to know that information is to have that disaggregated things all the time and be able to put it all together and then get after it, so I can give it to the combatant commander or whatever commander's there on the ground to be able to affect that change that they're looking for. Over.
Great, thanks. Well, gentlemen, we've covered a pretty wide waterfront of issues here. I want to save a little time for Q&A from our audience, but let me try to summarize quickly the need. We need a synoptic view of the weather, and we need that supports strategic and long-range planning. We need an operational view of the weather, which is what's going to happen in the next 24 hours, and we need a tactical view of the weather that can look at changes that happen hour by hour. And the way that you are planning to do this is by multiple constellations, 2 in low Earth orbit and 1 in geosynchronous, that will work together to provide the adequate types of sensors at the right time, as well as the refresh rates that are required by those different levels of command: strategic, operational, and tactical. Is that a good summary? Is that fair, Pat?
Yes, sir. I think it is.
Okay. And Joe, would you agree?
Yes, sir. The only thing I would add is that with the constellations that you mentioned and the orbits that we're intending to deliver these capabilities in, there is a family of systems that we heavily rely on with our partners in NOAA, the European Meteorological Agency, the Japan Meteorological Agency. And the only way that we are going to deliver the refresh rates that our DoD operators need today is to continue to work within that family of systems. And so we are absolutely a key part of that, but we will continue to leverage our partnerships as our CSO is looking for us to do to ensure that that capability is pushed.
So like in every other domain, our allies are really valuable and their capabilities to this mission set. Is that fair?
Yes, sir. 100%.
Terrific. And let me close just because General Van Herk has come up voice, you know, the defender of the North American continent, NORAD, NORTHCOM. And he, you know, you would think we'd had more than enough weather support here. You turn on the news at night, you got all kinds of weather. What more could he possibly want? But he brings up a great point to defend our homeland forward. We must be able to operate in the Arctic. And that requires not only domain awareness of sea states, et cetera, what's going on out there, but the weather. And will these new constellations address Arctic weather and the needs of General Van Herk for the defense of North America and the United States?
So I can take that from an operational perspective, and then Joe, I can answer it from an acquisitions perspective. First, we need to understand the environment of the Arctic, and no pun intended on that. The Arctic is not the equator region, and the Arctic is not the mid-latitude weather either. Within the Arctic, you have a lot less atmosphere than you do, say, somewhere else. You're also closer to magnetic field poles, to magnetic poles and to magnetic field lines, which means charging events and communications are a lot more vulnerable than they would be other places. And we just have a lack of observations in general in the Arctic area. So it's a data sparse environment like everywhere else. Geo orbiters don't look that far north, so I can't see using a geo orbiter what's up there. So I actually have to have a polar orbiter, and it has to be refreshed quite often to be able to see a time scale that makes any sort of sense. And so I need that polar orbiting capability to be able to determine the when and the where we should be able to do things. The SBEM capabilities that we're talking about with the polar orbiters and the low Earth orbiters would absolutely provide that piece of it. Otherwise, we're really flying blind up there, and whatever assets we put up there are going to be new, and it's going to take some time to ingest it and kind of figure out how that works and how that plays out over time. Getting those satellites up there will definitely speed up that whole entire process because we'll have eyes on all the time. Over.
Great. Thank you. Well, Tim, let me turn it control of the Q&A over to you. I think this would be a good time. We got about a little less than 10 minutes remaining for audience questions. So Tim, over to you.
Great. Thanks so much, General Chilton. Appreciate that. So to start with, we'll call on Sandra Irwin. Sandra, if you could go ahead and come up and unmute and ask your question. Thank you.
Thank you, Tim. Good afternoon. I have a question for Colonel Maguadog. The DMSP satellites, you have two in operation. How much service life is left in these two satellites? Do you have any up-to-date estimates on that?
Yeah, hi, Ms. Irwin. Thanks for the question. Right now, we are anticipating at least, I'll say, a few more years of life on these satellites, but we are continuously evaluating their capability going forward. And so we're keeping a close eye on ensuring that we've got successive capability to meet the need.
So if you have you're launching the CubeSat in 2024, and then you launch the small satellite in 2025, does that give you enough overlap so that you can, so you have something to replace DMSP under, these estimates that you have for the end of service life?
Absolutely. Just one thing I'd want to make clear is our CubeSat that we're launching is a technical demonstration. And so there's no intention for the CubeSat to meet operational need, more of us exploring some commercial capability at a very small scale, set up in a way that's never been done before. But the satellite that we're working on with General Atomics, that small size satellite on track to be delivered in 2025, it is absolutely the intent that it'll meet the DMSP need and provide more.
Thank you very much.
Great, thanks. So from our chat here, we've got one. Given the difficulty in fielding a DMSP replacement over the past 20 years, what has kept the SBEM from being able to achieve the advocacy push that it needs? Do we see that from its own success? What have you seen from SSC? I guess, Joe, we'll start with you.
Yeah, it's hard to comment on why this mission area has been challenged for so long. I guess I would say our leadership is continually evaluating the highest priorities of every service, right? And often we're in a physically constrained environment. And so inevitably, as people are trying to make decisions on certain missions and what can and can't be without, you've got communities in each area that want everything, right? And I think, and that's been a challenge. I think the goodness now and over the past couple of years in EWS is we have got a lot of strong support at the highest levels. And as long as we continue to stay on track and actually deliver, our goal is to stay under budget and not go back asking for anything, right? Because we want to prove that they can trust us to deliver on a capability. And thankfully, all the way up through my leadership, we've had a lot of strong support. And I would say as long as this team continues to deliver on the timelines that we need to meet the warfighter requirement, my hope is that we'll continue to get that support and we'll actually be able to deliver as expected.
Yeah, I'd pile in on this, having observed some of this in the past when these fine gentlemen were probably captains. But how you set up a program and who you pin the rows on to run it. We've tried shared responsibilities in various programs over the years, and they end up, because of various requirements from different agencies, leading to delays and cost overruns, in my view. And I think now, as opposed to some times in the past, it's clear that this requirement is going to be met by the work of Space Systems Command. And it's going to be operated by the Space Force to support the warfighters. And just having that singular responsibility given to the Space Force and to Space Systems Command to deliver these capabilities for the warfighter, I think will help solve some of the problems that were just asked by the questioner. Thank you.
Great, thanks, sir. So our next question comes again from our chat from Jim Bauer, and he talks about, and this is an interesting one, probably Joe, from your perspective, I guess, when we talk about some of the relationships, what, SWAC, the warfare center that has been designated to be able to get after requirements in the architecture. They've been doing a lot of work on the missile warning, missile defense side of the house, as far as being able to future force design on that. Are they examining the SBEM requirements, and what's that kind of attachment and involvement been?
Yeah, Tim, thanks. So the SWAC team has absolutely been getting after prioritized missions in certain orders, right? And so unfortunately, they haven't had a chance to get to the SBEM requirements yet, but there is a plan to do so, and I believe we're on the docket in the next year or two. But what I would say is, in the meantime, I think the acquisition community takes it upon ourselves as we work with these stakeholders at the various levels, as it is a DoD requirement, for us to continue to have that discussion with our stakeholders and not wait for the SWAC to provide a mission-specific analysis, right? We don't have the luxury of waiting a year or so when they get to it before we start moving out. And so that's why I think our relationship with the operational community has been so key over the last few years, is as we are trying to ensure that we're getting after the most current requirements, and being as agile in our acquisition strategy as possible to allow for scalability or any types of minor modifications. We're trying to put ourselves in the best position.
No, great. I appreciate that. So I think let's go ahead and pull one up here again from our chat here. Joe Johnson, who happens to work out at U.S. Space Command J8, and Pat, he's seen you in the past briefing different pieces and parts, but he wants to talk about, and again, this gets to the operational side of it. What is needed? You're a service director of weather, but how is it that each one of the combatant commands can make sure that they actually are raising the importance and being the voice for SBEM so that those operations, they're getting elevated up on the command's IPL, things like that? What do you see that can be done from a warfighter side?
Yeah, thanks for the question. So from a warfighter side, I think, and I think we mentioned it earlier on as well, we need advocacy, but we need advocacy, informed advocacy, I'll say it that way. So what we used to have, and we don't have anymore, but I think we really need to have again, is at each combatant command level, we used to have a senior METOC officer at the 06 level who understood how Air Force weather and how METOC, meteorology and oceanography, works in general, and can be able to converse with the J3, the J5, the 2, and the commander and the director of staff and the deputies on a consistent basis, and say, hey, these are the things that we're looking for. These are the things that we absolutely have to have so that we can get those things into the IPLs and be able to walk the dog and say, hey, if we don't have these capabilities, we can't provide this type of effect on the back end. And so if we can provide that capability back into those combatant commands and have the right advocacy at the right locations, I think that's where we need to focus. I'm currently in the half A3, and that's one of the talk points that we're having right now is how do we put those 06s back into the combatant commands, in those joint billets, to be able to have those conversations with those key leaders and key commanders to be able to have that advocacy discussion, whether it's with the joint staff, whether it's with the services, or whether it's putting it back in those IPLs so we can have those conversations, say, this is what we actually need, and be able to articulate it in a manner that makes sense and not just a whole bunch of science gobbledygook, but actually put it into some sort of operational, impactful, meaningful way that resonates with the people that they're going to have to chat with. Over.
Well, gentlemen, unfortunately, we've come to the end of our time. A great discussion. I can't thank Lieutenant Colonel Joe Maguadog or Colonel Pat Williams enough for the time you've spent with us today to help inform and educate our audience. And Tim, an excellent paper. I want to encourage everybody online, and I'm sure it'll get a lot of circulation, to download and read Environmental Monitoring for an Era of Peer Competition. It's more than just weather, and it's a true need that our warfighters require to successfully operate in the complex environments, specifically globally and in the Western Pacific. And the threats we see there, these capabilities are very essential. And Tim, I think you lay that out exceptionally well in your paper. And to all our audience from here at the Mitchell Institute, we wish you a great space power kind of day.